My goal each night is to post a video that we do each day, as long as my iPad cooperates and as long as the video uploads and all of that good stuff. If not, sometimes I'll have like videos from maybe like a previous year that maybe if I'm gone or sick, or if my video doesn't upload, it may not be a video from that year, but each day I'll try to post at least one video. I'll post it to Google Classroom. Along with the video, I will post the assignment. I'll give you the assignment at the end of each lesson each day, but I'll also post it in Google Classroom along with the video, so that if you didn't get it all written down or whatever, or if you're gone, you'll have access to the assignment and everything will be right there in Google Classroom. And we'll just kind of do it day by day. Each day we'll keep adding to it. Okay, so first up, intro to graphing. And I'll say this up front. Can you use your graphing calculator today? Absolutely. There really won't be any times where I'm going to say you can't use your graphing calculator. So if you want to have your graphing calculator out and use it as we go, sometimes it's more beneficial than others. There's sometimes where we want to use our graphing calculator every single problem, but there are some problems where it's not going to be real helpful, or we got to do some things to make it more helpful if we're going to use it. The first type of equation that we're going to talk about is a linear equation. A linear equation makes what type of shape? A line, right? Kind of right there in the word, linear. So all linear equations are going to make a line. Now, we've talked about these going all the way back to Algebra 1. We know that there's lots of different formats of a linear equation. There's some different examples of linear equations, and we're going to see some of those examples as we go throughout this chapter and throughout the year or semester. I'm going to show you some real basic ones. And I also will tell you this. In this section, they really just want you to make like a table of values and graph it, okay? But because we've graphed so much in previous years, doing different methods and doing different things, for me, I don't think that's always the easiest and quickest way to graph. So to me, if you want to graph and make a table of values and you want to use your calculator for that, that's okay too, okay? But I'm also going to talk about how we can use our calculator, or we can use some of the methods that we've learned throughout the years to make it maybe a little bit easier and not have to rely on our calculator to do absolutely everything for us. So making a table of values is great, but not necessarily something we have to do on every single one of these problems. I'm going to start off with what we call slope-intercept form. And I'm just going to a new page here so we can do this all on one page here. I'm going to give you an equation, and we are going to graph it here as well. And I'm going to pull up a piece of graph paper. I know you may not have a piece of graph paper readily available, but that'll make it easier for me to graph if I have a piece of graph paper. See if I can find a good one here. Okay. So slope-intercept form. Slope-intercept form y equals mx plus b. Okay? And once again, if you want to make a table of values, you can make a table of values. If we make a table of values, then your table of values is going to look like this. X is my input, Y is my output. I could put some numbers in for X. I could find out what the output's going to be, get a couple of points, make our line. Really, all we need to do to make a line is to have 2 points, right? That kind of goes back to geometry. Any 2 points make a line. So we need at least 2 points, but we could have a bunch. There would be an infinite number of points on all of these lines today. Going back, and in this section, like if you were to look at the textbook, it's not going to talk about slope, intercept, and all of that yet. It'll talk about that down the road. But I'm going to go ahead and talk about it today because that's really the way that we've graphed probably when we have an equation in slope-intercept form. And we're going to see some in slope-intercept form today. So for me, I think that's the quickest and easiest way to do it. So if I gave you an equation, y equals negative 4/3 x plus 2. That would be an example of an equation that's in slope-intercept form. This number represents our slope. This number represents our y-intercept. So going back to how we're gonna graph it, if we're going to use slope-intercept form to help us graph, what piece of information do we want to use first? The 2. Okay. If we were doing a table of values, Lane, we could plug a number in for x, right? I could plug in, let's say I start with 0. Plug in 0, get a y value. Plug in 1, get a y value. But especially when we have fractions, that gets a little bit messy. And so if we're just going to straight plot right out of slope-intercept form, we're always going to plot that y-intercept. Now the key is that it's the y-intercept, not the x-intercept. So we're going to plot that b value, which is 2. So we're going to go up 2 on the y-axis. That's my y-intercept. Yeah, Kendall?
Do you have like the little graphing table?
I have some. Anybody else want some? Anybody else wants to grab anything? You're welcome. Anybody else? Okay. Once we have that point at the y-intercept, my second step would be plot your slope from the y-intercept. Hey, now we might go way back. And you might remember that slope is represented as rise over run. We'll talk more about slope later on in the chapter, but I'm kind of bringing that in now because we're going to use it to help us graph. In this case, my slope is negative 4 over 3. That's my m. The number in front of the x is always my m. It's my slope. Okay, so this number represents my slope. The top number is my rise. And you might say, well, Mr. Rudy, you spelled rise a little bit weird. I like to do it that way because that tells me rise moves up and down. Rise is your y value. It tells you how much you're moving up and down. So that's why I spell it with a y rather than an I like it's supposed to be. It kind of helps us to remember we're moving up and down. And then my run is positive 3. So we're going to, from this point here, negative 4, we're going to go down 4, because that's my rise. A rise of negative 4 means we're going to go down 4, and we're going to go right 3. And then your third step is just plot your points and make your line. Okay. The nice thing about using slope is now I can simply get a ton of points really quickly. Okay. I could go down 4, right 3 as many times as I want to. And I could keep going, right? I also, and here's something to kind of point out. These two things are equivalent. It doesn't really matter where I put the negative at. The negative could be on top, the negative could be on bottom. We don't want it both, because if we have two negatives, we really make a positive, and that we don't want it to be positive. We want it to be negative. So I could either have negative 4 over 3 or 4 over negative 3, and those two are the same thing. The reason I like to show you that is now my rise is a positive 4, and my run is a negative 3. So if I go back to where I started, I could also go up 4, and I could go left 3. And that should be right along the same line. And I could go as many times as I want to do that as well. Okay, once I have a good indication, 2 would be enough. You might say, well, why do we need 4 points? We really don't. 2 is probably enough, but to get a little bit more exact line, it's probably better to have more than 2 points. And then we're just going to connect these points together. And we got our line. Okay? If it's a linear equation, it should make a line. If it doesn't make a line, what did we do wrong? What's going on? Okay. You guys kind of remember how to use slope-intercept form? Okay. And I will tell you this, okay? If you want to put this into the calculator, and the nice thing about the calculator here, another example of a linear equation is and I'm going to go ahead and give you the names of these forms today. You've seen them before, so I don't think that's a real big deal. Standard form, the generic form for standard form is ax plus by equals c. Okay, still linear, still going to make a line, but there's good and bad here. Okay, it's still a linear equation. But what I don't like about standard form, and you guys probably would agree with me, is that when we graphed out a slope-intercept form, we could just look at the equation and say, boom, there's my slope, there's my y-intercept. I can just graph right out of that equation. The numbers that are going to be represented here don't really have a meaning, okay? They're not really going to represent anything specific. So for instance, if I wrote an equation up here, and I'm going to put a piece of graph paper up again. The equation we're going to do is 2x minus 3y equals 12. Okay, looks just like this. Now you might say, oh, it has a plus sign instead of a minus sign, and that will be the case. Okay, it'll be positive, negative, subtraction, addition. The bad thing is the 3 numbers that we have here do not represent anything. They're not your slope, they're not your y-intercept, they're just numbers. Okay, they're numbers A, B, and C. And so there's a couple of different ways that we could do this. Okay, for me, what I think, and I'll show you a couple of different ways. I'll put another equation up here in just a second and show you another way you could do it. But what I like to do on something like this is I do what we call the cover-up method. And that's just what I call it. If you had another teacher for Algebra 1, Algebra 2, they might have called it something a little bit different, but I've always called it the cover-up method. I think once you see the method, you'll probably see it and probably have seen it before. Maybe they didn't call it the cover-up method. And here's what we do. We are going to find a couple of points, okay? But those 2 points specifically are going to be the x-intercept and the y-intercept. So we're going to find the 2 intercepts of the graph. If I am finding the x-intercept is on the x-axis. Okay, the x-axis is our horizontal axis right here. Any point that falls on that axis is considered to be or called an x-intercept of that graph. One thing that all these points have in common, if I asked you what is this ordered pair right here, what would we say? 1, 0, okay? So we're going to go right 1, and we're not going up or down at all, okay? So this would be 1, 0, 2, 0, 3, 0, 4, 0, and so on, right? Same if I went left. What do they all have in common? They have a y value of 0, okay? So x-intercepts always have a y value of 0 every single time, okay? Any point that's on the x-axis, okay? Y-intercepts are just the opposite. If I have a point that falls on the y-axis, then it falls on this intercept or this axis. As I go up, this would be 0, 1, 0, 2, 0, 3, and on up, right? And so here, any point that falls on the y-axis will have an x value of 0 every single time, okay? So all we are going to do here is we're going to plug, let's say I'm going to start with my x-intercept. I'm going to plug 0 in for y. So here's my y, right? Well, here's why I like to do this. Because what is 3 times 0? 0. That's pretty easy math, right? 3 times 0 is 0. Anything times 0 is always 0. So what I'm going to do, this is why I call it the cover-up method, I'm going to cover it up. So now I have an equation that says 2x equals 12. Can I solve that equation pretty quickly? Yeah, 12 divided by 2. And that gives me 6, 0. And then we're going to do the same thing for the y-intercept. This time, 0 is my x value. So I'm going to plug 0 in for x. 2 times 0 is still 0, always 0. And don't cover up the negative in front of the 3, though. So now we have negative 3y equals 12. And 12 divided by negative 3 is negative 4. Those are my 2 intercepts. How many points do we need to graph a line? 2. That's it. Okay? And we're good to go. So we're going to go 1, 2, 3, 4, 5, 6. Just make sure you put it on the right axis. So 6, 0 goes 6 to the right. 0, negative 4 goes down 4. And that's all we need to graph the line. Okay? So here's the good thing, bad thing. Okay? If you say, well, I love my calculator, I really like to use my calculator, I get it. I would too. And I'm not going to necessarily limit your calculator, but I can't put this equation right into my calculator. Because in order to put it into your calculator, it has to be in the y equals format. So you would have to do a little bit of algebra work to get y by itself. And that's not necessarily ideal. I think this is a lot cleaner, neater, easier. If you want to solve for y, be my guest. Sometimes solving for y might be a little bit easier. I'll show you one here in just a second where solving for y might be a little bit easier. It's totally up to you. Okay? If you're dead set on using your calculator, you're going to have to do some work to get it into the format to be able to use your calculator. You still would get the same line if you do all the work right. Okay. The last linear equation I'll do. 3x plus y equals 6. Okay, and this is what I was talking about before. I'm going to show you both methods really quickly here. If we did the cover-up method, because it's in standard form, that would probably be one of my go-tos. We always start with a 0 for y and a 0 for x. And I always write a little table of values out just so I remember that one's the x-intercept, one's the y-intercept. I like to do them separately. So I plug in 0 for y, I put it in here, I cover that up, I have 3x equals 6. 6 divided by 3 is 2. If I plug 0 in for x, 3 times 0 is 0, I cover it up, it's gone because it's 0. I'm left with y equals 6. So that is my y-intercept, 0, 6. Okay? And that would be pretty easy to graph. Okay? Doesn't take too long to get there. What some people would do here, and they might say, well, I really want to use my calculator. This one would be pretty easy to get into your calculator, okay? Because right now y is not by itself, but is it pretty easy to get y by itself here? Okay, what would I need to do to get y by itself here? Subtract 3x, exactly. okay? Now, what you got to remember here is combining like terms. Because the 3 has an x attached to it, you cannot combine them together, right? You can't take 6 minus 3x. And if we put it in the form that we want here, slope-intercept form, we always put the x in front when it's in slope-intercept form. There's nothing wrong with writing 6 minus 3x, but putting negative 3x in front probably would be more familiar to us, a little bit better way of writing it out. Okay, I'm just going to do this one freehand real quick. If I did the cover-up method, 2, 0 is my x-intercept, 0, 6 is my y-intercept, right? That would have been enough. If I would have done it using slope-intercept form, my slope, my y-intercept, my slope here is negative 3 over 1. My y-intercept is 6. Guess what? My y-intercept is still 6. Okay? And then what I could do is I could go, here's my rise over run, down 3, right 1. 1, 2, 3 over 1. Guess what? It's on the line. 1, 2, 3 over 1. Still on the line. Okay? So do you have to do both? No, you do not have to do both. I'm just showing you how the two kind of interact and relate to one another. And just pick out which one makes more sense to you or you think is the easiest for that particular problem, and we're good to go. Okay? Questions on that one? You guys kind of remembering all the graphing of lines? Like I said, if you need help with the calculator, get with me, but I think that's something that you guys did a lot of in Algebra 2, so I think you're pretty familiar with it, and since most of you have the same calculator that you use, then I think we should be good there. All right, so they're all linear equations. They all made a line. This next one is a little bit different equation. Hey, what's different about this equation than what we've seen so far? It's got an exponent, okay? And not only does it have an exponent, but what kind of exponent does it have? Exponent of 2, okay? Squared is what we usually call it, right? 2x squared is what we would read this equation as. Y equals 2x squared. When I have an exponent of 2, what type of equation do we call that? I think I heard it. Quadratic, yeah, okay. What's special about a quadratic equation? What kind of graph does it make? Remember? You got quadratic part, right? Parabola, yeah, it's a U-shaped graph, okay? So this is what we call a quadratic equation. It's just the name of the equation. We'll get a lot more in depth with quadratics as we go throughout the semester, but for right now, it's just kind of remembering the name of it, okay? It always makes a U shape. Can I put this one into my calculator? Yeah, because it's y equals, right? And that would probably be a quick and easy way to go. If you're going to do it, just to make sure that you're accurate, you probably want to make sure you get multiple points. Okay, and here's what I would recommend doing. First of all, if I graph this one, and I'm just going to freehand this one too, just to save a little bit of time. 0, 0, that's what we call the vertex of the graph. That's where it's going to come down and hit, and it's going to bounce back up. If you put it into the calculator, you can see that. That's one of the points that's on it. But because it's a U-shaped graph, we got to find some points on either side. So some points on either side. How many points that you use or how big that I go, try to keep it as simple as possible. 1's an easy number to plug in. 2 should be pretty simple to plug in. Sometimes the bigger numbers you use, you might get some really big y values, depending on what the equation is. So here, if I plug in 1, just to talk about the input-output really quick, and where do these y values come from, always do order of operations, right? 1 squared is 1. 1 times 2 is 2. So we have to do order of operations when we do the input, okay? Can my calculator get me that table of values? Sure it can, but it's also good to know where do those points come from? Why do those points give me what they give me? Okay. Secondly, when I plug in a negative, when I square a negative, what happens? Back to positive, right? And so it becomes a positive 1, and 1 times 2 is 2. So positive 1 and negative 1 give me the same y value, the same output. When I plug in 2, 2 squared is 4. 4 times 2 is 8. Okay, that's a perfect example of why we have to do order of operations first, because I'm telling you right now, one thing that some people will do here is they'll put 2 in right here. They'll do 2 times 2, which is 4, and then they'll square the 4. Well, that is not the order of operations, which is something we talked about way back when. When you put those in, if you were going to do the math, you would have to do the order of operations. Otherwise, you'll get a different value, you'll get a different output, and it'll look different. When I plug in negative 2, guess what? I'll get the same thing. And so just real quickly here, 1, 2, negative 1, 2. Right 1 up 2, left 1 up 2. Okay? 2, 8. Negative 2, 8. Okay, when you do a parabola, parabolas are a U-shaped graph, and they are always symmetrical. Okay, symmetrical means there's a line that splits it right down the middle. In this case, the y-axis is splitting that graph right down the middle. So when I look at these points, they are on symmetrical to that y-axis. These 2 points are flipped over that axis of symmetry. Okay, and those are all terms that we'll get to more in depth later on, but probably terms that you've seen and heard of before. Okay, one more. Quadratic equation. You might remember some rules from when we did parabolas and did quadratics in previous years. We do it just real briefly in Algebra 1, and then we spend a lot more time in it in Algebra 2. And you might remember some of those rules, and that might kind of help you to remember like what's going on here. So if I see a plus 3 after the x squared, anybody remember what that does to the graph? Raises it up 3. Okay, if it was minus 3, it would go down 3. Okay, when I have a negative in front of the x squared, what does it do to the parabola? Flips it upside down. Good. Okay, so do you have to remember those right now? Not necessarily, but we've talked about some of those changes, and you might be able to kind of pull that in and use some of that previous knowledge to help us. Okay, but when I graph this one, and what I would do here is you could, and we'll come over here and we'll say 0, 3, 1, 2, negative 1, 2, 2, negative 1, negative 2, negative 1. Those would be 5 quick and easy points, and I got them right off my calculator. If you want to do the math, then by all means you could do the math, but I'm just trying to show you that you could go a shortcut here. Okay, still a parabola, still a U-shape, just a little bit different location and upside down and that kind of thing. Okay, there are a couple of formulas today that you're going to see, and these are formulas for the most part. I think 2 out of 3 I know we've definitely seen before from geometry. The third one, maybe not, depending on how much you've covered. So the first formula is the distance formula. Okay, we cover this a lot in geometry. We use this at a lot of different times in geometry, but it's been a while since you've probably seen this. I don't think we do it much in Algebra 2. I'm going to give you the good old generic distance formula. x2 minus x1 squared plus y2 minus y1 squared, and we take the square root of the whole thing. Okay, I'm going to show you why and where we would maybe use the distance formula and where it kind of applies to what we're doing in some of the other problems today. First of all, you're going to be given 2 points. Okay, so the 2 points I'm going to give you here are -2, -3, and 4, 1. Okay, we're going to plot these 2 points. I'm going to connect them together as a segment, and that is my segment. And what we are looking for is how long this segment is. What is the length or the distance of that segment? I can't just count because it is diagonal, okay? If it was horizontal or vertical, I could count 1, 2, 3, 4, and so on. Can't do that when it's diagonal. So what we're going to do is we're going to use the distance formula. We're going to label these 2 order pairs as x1, y1, x2, y2. First x, first y, second x, second y. That's all that means. It doesn't matter which one comes first, which one comes second. I could label this one as x1, y1 if I wanted to. Okay, order doesn't matter here. We're going to plug this into the formula. So we're going to go x2 minus x1. Really watch your signs here. 4 minus -2 squared. And then y2 minus y1 would be 1 minus -3 squared. Just inserting those numbers right into the formula. The reason you got to be careful of your signs, 4 minus -2 really means 4 plus 2. 4 plus 2 would be 6. 6 squared is 36. 1 minus -3 is 1 plus 3, which is 4. 4 squared is 16. And that gives us the square root of 52. Okay? That doesn't mean a whole lot, probably. If I said something is the square root of 52, if I went into Lowe's and said, could you please cut me a board that's the square root of 52 feet long? Probably would look at me like I'm a little bit weird, right? But maybe that would be kind of fun to have a little bit of fun with them too, maybe. I don't know. Probably not. It'd be kind of weird, probably. Okay, so radical 52 doesn't tell us a whole lot. If I said, how long is this? You wouldn't say, oh, it's about radical 52 units long, right? But what is radical 52? Well, I can take the square root of 52 in my calculator, and it's about 7.1, 7.2. Okay. And then we always use U for units long. So this is about 7 units long. Okay, I'm going to put the midpoint formula right below that. Okay, the midpoint formula, also another one that we've seen before. Okay, we got this one, we got one more. We'll try to get through it all here. I'm going to use the same 2 points from up above. The midpoint formula is finding the midpoint of a segment. The difference here is that my answer is going to be written as an ordered pair. What is the point halfway in between? So I'm going to use the same 2 points that I had up here, okay? And I want to find the point that's halfway in between those 2 points. The 2 points that I gave you up here were -2, -3, and 4, 1. Once again, I'm just going to label them real quickly here. x1, y1, x2, y2. We're going to go -2 plus 4 divided by 2. -3 plus 1 divided by 2. We're going to do a little bit of math. -2 plus 4 is 2. 2 divided by 2 is 1. -3 plus 1 is -2. -2 divided by 2 is is negative 1. So we're saying the point, 1, negative 1, my graph may not be perfect here, but 1, negative 1 is the halfway point of those two. So it looks about right. So we call that the midpoint of that segment. Okay, sometimes it's a decimal or a fraction, so that's why we can't just eyeball it and say, oh, I can kind of see where the midpoint is. The last one we're going to talk about here is the equation of a circle. And I'm going to keep this pretty straightforward. You have 3 pieces of information. Really 2. Your center is recognized as HK. HK is the ordered pair for that. And R is the radius. So if I tell you that I have a center at negative 3, 4, and my radius is 5. This is my H, this is my K. Those numbers get plugged right into the formula. So we're going to go x minus negative 3 is x plus 3 squared, because we subtracted a negative. We always put a plus sign in between. My K value is 4, so that would be y minus 4 squared equals 5 squared, which is 25. So we're just going to take those 3 pieces of information, put it in for h, k, and r, and that's my equation. No solving it, no work to do. That's your equation. Okay, I'm going to put the assignment up here. I know we're running short on time. If you don't get it written down before you leave today, I will also put this on Classroom tonight. Remember, homework's not due like tomorrow, but you probably should be working on it as you go. If you need some graph paper before you leave, I think I have some sitting over there because we will be doing some graphing today. It's not required, but if you would rather do it on graph paper, it may not be a bad idea. And I just kind of go through and pick these problems out. That's why it kind of seems like a lot, but it's probably no more than what you're used to doing most days. I'll post that on Classroom as well, so it'll be up on Classroom tonight. Probably 7th hour is usually when I'll get that done.